The following questions all revolve around batch processes. In this case, we're going to look at question 2 and give you a few hints on how to solve this question. Here on the left, we see depicted the batch process and the batch reactor. In this case, we see that acid and base is added to maintain a steady pH within the liquid broth. Moreover, a bit of air is added to maintain a fully aerated broth. Batch processes are characterized by very specific profile. This profile is of the number of cells within the reaction changing over time. Initially, we see a lag phase, which was discussed in question 1. Then we see an exponential growth phase, followed by a stationary phase, and ends with cell death. In this case, we are asked to focus on the exponential phase, as this is the phase that follows upon the lag phase. So what kind of parameters do we have to look at? Well, the first thing is the mass of our broth. In general, we say that the mass of a broth of a batch system will remain constant. But in this case, we have a bit of acid and base reaction, which are liquid streams. Therefore, the mass of our broth will slowly increase over time. During the exponential phase, the biomass will grow at a mu, or a growth rate of mu max. Also, all biomass-specific conversion rates of each compound Y will remain constant. By making this assumption, you can also relate to the process reaction. Recall that the process reaction was derived based on the biomass-specific conversion rate. For example, for the substrate, it is defined as follows. Then we can also have the nitrogen source, and we could add any other reactant that we wanted. Then on the right side of the reaction, we would have our biomass and our product and any other product that would be formed. Now, by making the assumption that Qi is constant, you can derive yourself what would happen to the process reaction. A few other interesting parameters that we have to look at is the number of cells and how it changes over time. We can derive a relation for this that you have seen before and is equal to nx at t is 0 multiplied by the exponent of mu max times t. For our reaction rate, or our biomass production rate, we see that it is equal to mu max multiplied by the number of cells at a certain time point t. Now you can derive yourself what this implies for how they change over time. Is this exponential or not? The final parameter we have to look at is the concentration of biomass, how it changes over time. The question is whether this is exponential. By looking at previous derived relations and also the assumption that we made here in the beginning about the mass of our broth, you can derive whether the concentration change over time exponentially or not. I hope that this will give you a framework on how to solve question 2 and how to solve any other further questions related to batch processes.